All right, welcome everyone. In today's video, we are going to look at hypothesis and hypothesis testing in statistics. Now, let's begin with the word hypothesis. Now, when we say hypothesis, hypothesis simply means a testable statement, okay? A statement that may either be true or false. So, for example, I can make a statement that there is a relationship between exercise and hypertension. Okay, I can make a statement that there is a relationship between exercise and hypertension. Now, this is a statement that we can test because why? This statement over here, it can be true or false. Okay, so when we say a hypothesis, hypothesis simply means a testable statement. A statement that can either be true or false. Now, during a football game, usually we have two teams, Team A, and then we have Team B. Now, prior to the game, I can make a hypothesis that Team A will win. Someone else can also make a hypothesis that Team B will win. But look at this. This statement, these two statements can either be true or false. It could turn out that Team A will win. It can also turn out that Team B will win. Now, when we say a hypothesis, it simply means a testable statement. Okay, that statement can either be true or false. Okay, so hypothesis simply means a testable statement. Or you can say a statement of prediction. Is that okay? So hypothesis is more like you are making a prediction. That prediction can be true or false. Again, a hypothesis can be tested. Is that okay? For us to know whether the hypothesis is true or false. That's why we say a hypothesis is what? A testable statement or a statement of prediction. Now, in statistics, hypothesis is usually in two forms. So we have types of hypothesis or forms of hypothesis. So we have types or forms of hypothesis. Now, in statistics, we have two forms of hypothesis. We have the null hypothesis and then we have the alternative So we have the null hypothesis and we have the alternative hypothesis. Now, for two given variables, when we give you two given variables, the null hypothesis is going to tell us that there is no relationship between the variables. So when we give you two given variables, null hypothesis is just going to make a statement that there is no relationship between the variables. So null hypothesis will go like, there is no relationship between variables. Now, for two given variables, the alternative hypothesis is going to tell us that there is a relationship between the variables. Is that okay? So for two given variables, null hypothesis is just a statement of prediction. That is going to tell us that there is no relationship between the variables. For two given variables, the alternative hypothesis is just going to tell us that there is a relationship between the variables. And all the time, variables will be emphasized. So let's look at an example. Let's look at an example. So let's say we give you smoking, we give you two variables, smoking and lung cancer. So these are two variables. And we ask you to write hypothesis. It's simple. Once we tell you to write hypothesis, it's simple. You have to remember that once you are asked to write hypothesis, you are going to write two hypotheses. The null hypothesis and the null hypothesis, you can represent it by HO. Then the null hypothesis, these two variables, you are just going to write a statement that there is no relationship between smoking and lung cancer. There is no relationship between smoking and lung cancer. Alternative hypothesis. H1 or HA. Alternative hypothesis, you are just going to write there is a relationship between smoking and lung cancer. So when we give you two variables and we ask you to write the hypothesis, you are going to state two hypotheses. The null hypothesis, which is the H naught, and the alternative hypothesis. The null hypothesis, you are just going to write, there is no relationship between smoking and lung cancer. The alternative hypothesis, you are going to write, there is a relationship between smoking and lung cancer. So you see that this hypothesis is establishing that there is a relationship between the variables. And this hypothesis is also establishing that, this one is establishing there is no relationship. And this one is establishing that there is a relationship. Now let's look at another example over here. Exercise and hypertension. Okay, so these are also two variables. If I ask you to write hypothesis using these two variables, you are just going to write null hypothesis then you write there is no relationship between exercise and hypertension. Alternative hypothesis. There is a relationship between exercise and hypertension. Is that okay? So when we give you two variables, the null hypothesis, you are just going to write that there is no relationship between exercise and hypertension. So it's just about you making a statement to tell us that there is no relationship between the two variables. So the null hypothesis, there is no relationship between exercise and hypertension. The alternative hypothesis, there is a relationship between exercise and hypertension. We can also give you this variable, sleeping under insecticide-treated nets and malaria. So for these two variables, sleeping under IT and insecticide-treated nets and malaria, the null hypothesis you are going to write, there is no relationship between sleeping under insecticide-treated nets and malaria. Alternative hypothesis, there is a relationship between sleeping under insecticide-treated nets and malaria. Is that okay? So that is how we write it. And remember, anytime we ask you to write hypotheses in statistics, and usually in research, you have to write two hypotheses. The null hypothesis, which is establishing that there is no relationship between the variables, and the alternative hypothesis, which would come in to establish that there is a relationship between the variables. Okay, so now you know the various types of hypotheses that we have. The null hypothesis and the alternative hypothesis. Okay, now again, we can use hypotheses to check the relationship between categorical variables. We can also use hypotheses to look at the relationship between quantitative variables. Is that okay? And that is where the various types of hypotheses also comes in. Okay, so let's come back to an example, smoking and lung cancer. Now, if I ask you to write the hypothesis, how are you going to write it? You write your null hypothesis, and then you write your alternative. Now, this null hypothesis, you can represent it by this symbol, H0. The alternative hypothesis can represent it by H1 or HA. So if you write H0, it's the same as the null hypothesis. If you write H1, it's the same as alternative hypothesis. So this smoking and lung cancer, the null hypothesis will say there is no relationship between smoking and lung cancer. Alternative, on the other hand, will say there is what? There is a relationship between smoking and lung cancer. Now, one thing you should know is that, you see, look at this hypothesis. This one is saying there is no relationship between smoking and lung cancer. They're saying there is a relationship. Now, in some literatures, you see there is no relationship. They'll say there is no statistically significant. So they will say there is no statistically significant relationship between smoking and lung cancer. It's the same thing. You can use it. You can also say there is no statistically significant association. Instead of the word relationship, some literatures, they use association. So there is no statistically significant association between smoking and lung cancer. Then when you come to the alternative, you can also say there is a statistically significant association between smoking and lung cancer. Or you can say there is a statistically significant relationship between smoking and lung cancer. You can use that to is accepted. Okay, again, you can even write it as a mathematical equation like this. So I can write H0 here represents the null hypothesis. So I can write it this way. I'll pick the first variable, smoking, then is equal to, then I cancel it, lung cancer. This one too is the same thing. So this one means smoking is not equal to lung cancer, meaning there is no relationship between smoking and lung cancer. But if you are using this equation, be very careful. If you don't cancel it, you've not written what null hypothesis actually means. You've rather written for the alternative hypothesis. Okay, so when you write H0 is equal to, smoking is not equal to lung cancer, this one also means there is no relationship between smoking and lung cancer. It's also correct. You can also write H1 or HA, smoking is equal to lung cancer. This one also means there is a relationship between smoking and lung cancer. So in some books, this is how they are going to present it. It's the same thing. It depends on how you understand it. So when I write smoking is equal to, then you slash it. You cancel the is equal to. It means there is no relationship between smoking and lung cancer. Then H1 or HA, smoking is equal to, meaning there is a relationship between smoking and lung cancer. But please, usually go with this one. Go with the statement form, please. All the time when you are asked to write hypothesis, go with the statement form. Now let's look at some errors in hypothesis testing. Errors in hypothesis testing. Now let's come back to this hypothesis. So you see, I told you there are two hypotheses over here. The null hypothesis and the alternative hypothesis. So what it means is that if you are to make a choice, there are two options. You can either go in for this or you go in for the alternative. Now, if you tell us that you've rejected the null hypothesis, if you tell us that you've rejected this, there are two chances. What it means is you've accepted this one. The moment you tell us, because you see there are two hypotheses. If you tell us you've rejected the null hypothesis, it means you've accepted the alternative hypothesis. Okay, again, if you tell us that you've rejected this one too, you rejected the alternative hypothesis, it means you've accepted the null. That's the meaning. So because there are two hypotheses, the moment you tell us you've rejected this, it means you've accepted this. And if you tell us you've rejected this one, it means you've accepted this one too. Is that okay? Because there are two chances over here. Is that okay? Now, let's look at this hypothesis. The null hypothesis. There is no statistically significant relationship. Now, in all situations, the hypothesis that tells us that there is no relationship between variables is also a negative hypothesis. It's negative. So in all situations, that hypothesis that is always telling you there is no relationship between the variables is a negative hypothesis. And the hypothesis that is telling us there is a relationship between the variables is a positive hypothesis. What that means is that the null hypothesis is negative. The alternative hypothesis is what? Is positive. Okay? And usually I say that the null hypothesis is more like the natural hypothesis. That hypothesis that would always come to tell us that for two given variables there is no relationship. That's the natural one. Because that's the one that you should consider natural. Okay, now the hypothesis that is coming in to tell us there is a relationship between the variables is like artificial. Because that one is now going to establish that there is a relationship between variables. Now, the one telling us there is a relationship is a positive hypothesis. And the one telling us there is no relationship is a negative hypothesis. Now, let's assume that, see, we have two statements. No relationship. There is a relationship. This one is saying for smoking and lung cancer, there is no relationship. Alternative is saying for smoking and lung cancer, there is a relationship. Let's assume that in actual sense, the statement that is telling us there is no relationship, that statement is true. Let's assume. Let's assume that this statement, this one, in actual sense, is a true statement. Meaning, let's assume that the null hypothesis is actually true. But during your decision making, you rejected it. Meaning, when you reject this, it means you've accepted this. So in a situation where this null hypothesis, it is true. But during your decision making, you rejected the null hypothesis and you went behind the alternative. You've committed an error we call the type 1 error. Type 1 error. So you see, there are two hypotheses over here. The null hypothesis and the alternative hypothesis. Null is saying there is a relationship. Alternative is saying there is no relationship. Let's assume that the null hypothesis is actually true. And you rejected the null hypothesis, meaning that you've accepted the alternative. In such a situation, you've committed an error we call type 1 error. Okay, and remember I told you that the null hypothesis is negative. The alternative hypothesis is a positive statement. Okay, so in that situation, you can also call this type 1 error false positive. So that means that You've gone behind the positive hypothesis. Meanwhile, it is false. And that's why we call it what? False positive. Okay? So another name for type 1 error means false positive. So type 1 error simply means rejecting null hypothesis when it is true. Okay? When we say type 1 error, it simply means you've rejected the null hypothesis when it is true. Okay, so in natural sense, let's say this null hypothesis is true. You rejected it. Let's take stealing. Let's take students and stealing. Let's say that in a certain class, something gone missing in the class. In a certain class, something gone missing. And there is a particular student everyone is suspecting. Is that okay? There is a student that everyone is suspecting in the class. Now, the null hypothesis is going to tell us that there is no relationship between the student and the stealing. The alternative hypothesis is going to tell us that there is a relationship between the student and the stealing. Now, you are a judge. We bring this case to you. There are two statements. There is no relationship between the student and the stealing. There is a relationship between the student and the stealing. Let's assume that in natural sense, the student actually stole it. Let's assume the student actually stole the phone, or the student is involved in the stealing. What it means is that the alternative hypothesis is true. What that statement means is that the alternative hypothesis is true. Now, in a situation where, let's say, during your decision making as a judge, you rejected the alternative hypothesis when it is true, you've committed an error we call type 2 error. Is that okay? Type 2 error is also called false negative. So we have a student, we have stealing. The null hypothesis is saying there is no relationship between the student and stealing. The alternative hypothesis is saying there is a relationship between the student and stealing. Let's assume that truly the student is involved in the stealing. Truly, let's assume. And during your decision making as a judge, you went ahead to reject the fact that the student is involved in the stealing. Meaning in this situation, you've declared the null hypothesis to be true when it is false. Okay, that type of error, we call it type 2 error. So type 2 error simply means rejecting alternative hypothesis when it is what? True. Or failing to reject null hypothesis when it is failing to reject the null hypothesis when it is false. Is that okay? When we give you two, let's come to these variables. Null hypothesis, alternative hypothesis. There is no statistically significant relation between smoking and lung cancer. There is a relationship between smoking and lung cancer. Let's assume that the hypothesis that is saying there is no relation, there is a relationship. Let's assume the alternative is true. Now, the alternative is true over here, but you went ahead to reject the alternative. Meanwhile, it is true. In such a situation, you've committed type 2 error. Type 2 error is when you reject the alternative hypothesis when it is true. And that's why the type 2 error, we call it false negative. False because, you see, the null hypothesis is the negative hypothesis. So if you reject the alternative hypothesis, it means you've accepted this. In a situation where the alternative is correct, but you fail to what? You reject the alternative hypothesis when it is correct, you've committed what we call type 2 error. And that's why the type 2 error We also call it the false negative. False negative. Rejecting alternative hypothesis when it is true. Type 1 error. Rejecting null hypothesis when it is true. Type 1 error. Okay, so we have two types of errors. Type 1 error, and then we have type 2 error. What is type 1 error? Type 1 error is when you reject the null hypothesis when it is true. We also call it the false positive error. What is type 2 error? Rejecting alternative hypothesis when it is true. We call that type 2 error, or you can call it false negative. So now look at this. So you see we have null hypothesis. There is no relationship between smoking and lung cancer. Alternative hypothesis, there is a relationship between smoking and lung cancer. So you see we have two hypotheses here, meaning you have two chances over here. It's either you go in for the null or you go in for what? The alternative. Now during the decision making in statistics, we do not use the word accept. Do not use accept. You don't use accept when you are doing hypothesis testing. Okay, we don't want you to use the word accept. So how do you make a decision? This is how you do it. So let's assume you want to accept the null hypothesis. We don't use the word accept. So what you can say is that instead of saying accept, remember there are two hypotheses. If I want to accept this null hypothesis, I will say I reject alternative. Okay? If I want to accept the null hypothesis, we don't use the word accept. So instead of saying I accept the null hypothesis, I will say I reject the alternative. Once I say I reject alternative hypothesis, automatically means I've accepted the null because there are two. So if I tell you I've accepted this, I've rejected this, it means I've accepted the null. Again, another way I can say it is that I can say, instead of using the word accept, I will say I fail to reject. Okay? I can use the statement fail to reject. Okay? So if I tell you I fail to reject, it means I've accepted. Why are we using fail to reject? We do not use the word accept. Okay, so if you want to make a decision on hypothesis, it's two things. If you want to accept the noun, you have two ways to say it. The first statement, you can say that I reject alternative hypothesis. So if you tell us you've rejected alternative hypothesis, it means you've accepted the null hypothesis. And if you tell us that you've rejected the null, so in a situation where you want to accept the alternative, you say, I reject the null hypothesis. Once you say you reject the null hypothesis, it means you've accepted this. Or you can say you fail to reject alternative. Once you say you fail to reject alternative hypothesis, that one too means you've accepted the alternative hypothesis. So the point is that we do not want you to use the word accept. So when it gets to the decision making and you want to accept the null hypothesis, instead of saying accept the null hypothesis, you say I reject alternative. The moment you say you reject alternative, it means you've accepted the null. Or you say that you fail to reject the null hypothesis. That one also means you've accepted the null hypothesis. The point is that we do not want you to use the word accept. Okay, so when it gets to the decision making, remember, in a situation where you want to accept the null hypothesis, you have two ways to say it. You are going to say, I fail to reject the null hypothesis, or I reject the alternative hypothesis. That means you've accepted the null. If you want to also accept the alternative, you will say, I reject the null hypothesis, or I fail to what? Reject the alternative hypothesis. That is how we make decisions in statistics. So with this foundation, we can now start looking at some details. Now let's look at a concept we call confidence level. We have what we call confidence level. Now when we say confidence level simply means the measure is more like a measure of how accurate a statistical result is. Okay, it gives us an idea or probability of how accurate a statistical result is, or how accurate a statistical procedure or method is. That's the confidence level. Now, let me give you a practical example of confidence level. For example, you are going to do an exam, and I ask you, how confident are you in these exams? The exams you are going, how confident are you? You can say that, okay, I'm 98% confident. Is that okay? So when I ask you, okay, these exams ahead of you, how confident are you? You can say, okay, I'm 98% confident. Okay, this 98% confidence is just telling us how, how sure you are. Is that okay? Or more like the likelihood that you are going to pass the exams. So meaning you are 98% sure that you pass the exams. Now in statistics, when we say confidence level is basically the measure of how accurate a statistical procedure is, or a statistical method is, or a statistical result is. So for example, if you are calculating for mean in statistics and you get an answer, let's say you are calculating mean age of, let's say, patients on a pediatric ward, and you get an answer of 5 years, and I ask you, what is your confidence level? It simply means the procedure you use in calculating the mean and the answer you've gotten. How confident are you? Then I'll tell you, okay, I'm 95% confident. Is that okay? So confidence level is basically a measure of how accurate a statistical procedure or a statistical method is. Okay? Good. But then the example that I give, you are going to write exams. You tell us your confidence level is 95%. Now, one thing you should also note is that if you say your confidence level is 95%, it also means you've given 5% to chance. You've given 5% to chance that you commit an error. Because you see, you are telling us your confidence level is 95%. It means that 95% of the time you are sure you pass the exams. But 5% of the time you are sure you can also fail. So this 5%, you've given it to chance. Now in statistics, this is the confidence level. And this one is significance level. So the significance level is more like the level that you've given to chance that you fail or you commit an error. Is that okay? The confidence level is the level that you are sure that the test will be accurate or the procedure will be accurate. Now in statistics, this is the significance level. This significant level, you can also call it the alpha. So for example, if you are going to do any statistical test or analysis or procedure, you set your confidence at 98%. You just subtract it from 100. What it means is that your significance will be 2%. You are going to do a statistical test. You set your confidence at 90%. What it means is that your significance will be 10%. You are going to do a statistical test. You set your confidence at 99%. What it means is that your significance will be 1%. Is that okay? So now the significance can be expressed in percentage, okay, 2%, 10%. So if I ask you that a statistician is performing a statistical test and he set his significance at 5%, 5% significance means that person is 95% confident. If I ask you that, okay, a statistician is going to perform a statistical test, he set his significance at 3%. That means that his confidence is 97%. His confidence is 97%. Okay, so we can give you the significance and we will ask you to write the confidence. We can also give you the confidence level and ask you to write the significance. So we can give you the confidence level and ask you. So if a statistician is going to perform a test, he sets his significance at, let's say, 15%. What that means is that his confidence level is 85%. If a statistician is going to perform a test, he sets his significance at 12%. What will be the confidence level? 88%, right? Good. So you see, every confidence level comes with a corresponding significance level. And remember, the significance level is also called the alpha. So if a statistician is going to perform a test and his confidence is 95%, what it means is that the significance is 5%. But this 5%, you can also write it at 5 over 100. And 5 over 100 is 0.05. Is that okay? But usually the alpha, remember significance is equal to what? Alpha. But usually the alpha, we want you to write it in the decimal expression. But the significance, you can say significance. So for 95% confidence interval, significance can be 5%. Or you can say 5 over 100. Or you can say 0.05. But when you are writing alpha, write the decimal one, 0.05. Okay, so I can tell you, I can ask you that, okay, a statistician is going to perform a statistical test. He sets his confidence at 98%. What will be the alpha? The answer, we prefer that you say 0.02. But if it is about significance, you can say the alpha significance can be 2%. It can be 2 over 100. Or it can be 0.02. But if it is about alpha, use this. But remember, significance is the same as what? Alpha. Is that okay? So anytime we give you a confidence level, every confidence level comes with significance. So you are doing a statistical test, you set your confidence level at 98%. Your significance level will be what? 2%. Alpha level will be what? 2 over 100, which is equal to 0.02. You are going to do a statistical test. You set your significance at 98%. Your confidence at 99%. Significance will be what? 1%. And then this will give you 1 over 100. This will give you 0.01. You are going to do a statistical test. You set your confidence at 95%. Significance will be 5%. So alpha will be what? 0.05. Remember, alpha is the same as significance. You set your confidence at, which one haven't we done? 90%. Significance will be what? 10%. Alpha will be what? 10 over 100. That will be 0.1. So you see, every confidence level comes with a corresponding significance and alpha level. Every confidence level comes with a corresponding significance and alpha level. And this significance level is the percentage that you've given to error. Okay, so it's the significance level. That is more like the rejection Rejection region is the region that if your statistical test you come to, you reject. Meaning, is the point that if your statistical test you come to, you reject. Or you reject the null hypothesis. Meaning, if your statistical test progresses to the significance level, you reject the null hypothesis. So we call it rejection region. This is the rejection region in every statistical analysis. Is that okay? Great. So let's proceed quickly. Now, the last term that I'm going to introduce you to is what we call p-value. Then quickly we can do the last concept I'm going to introduce you to is what we call p-value. Now, p-value simply means the probability of obtaining an extreme result in a situation where the null hypothesis is true. Probability P-value is simply the probability of obtaining extreme results in a situation where null hypothesis is true. Now, let's look at a practical example. Let's say students are writing exams, and there is a particular student who is guessing. There is a student somewhere who is guessing. So now it means we have two events here. We have guessing and then passing exams. So you see, we have guessing and passing exams. But now the question we have to ask ourselves is, now let's state the hypothesis. So we have the null hypothesis. The null hypothesis is going to say guessing is not equal to what? Passing exams. Alternative hypothesis, H1 or HA. Guessing is equal to passing exams. So you see, we have the null hypothesis. It's telling us guessing is not equal to passing exams, meaning there is no relationship between guessing and passing exams. Now, alternative hypothesis is saying guessing is equal to passing exam, meaning there is a relationship between guessing and passing. But let's ask ourselves, if you are writing exams and someone is guessing, is there a possibility the person will pass the exams? Naturally, the answer is no. There is no relationship between guessing and passing exams, naturally. Because if in writing an exam, for you to pass, you should know. So here, all it means is that the null hypothesis is what? Is true. So there is no relationship. Now, so you see, there's a practical situation where we can tell clearly that the null hypothesis is true. But some way, somehow, the results come, and the student that is guessing turns out to get 40 over 40. Is that okay? So here you see, something extraordinary has happened. The student didn't just pass. The person has passed with an extreme result that we didn't expect. And you see here, this event is actually disproving the fact that the null hypothesis is true. So in a situation where null hypothesis is actually true, but someone obtains an extreme result that is supporting the alternative hypothesis, that probability, the probability that someone will obtain an extreme result in a situation where the null hypothesis is true, or the probability that someone obtains an extreme result to support the alternative hypothesis in a situation where the null is actually true. So you see, in this situation, the null hypothesis we can tell is true because you see, There is no relationship between guessing and passing exams. We know that the null hypothesis is true. But some way, somehow, someone has obtained an extreme result that actually supports the alternative hypothesis. That chance, that probability, is what we call p-value. So in a situation where you obtain an extreme result, in a situation where we can clearly tell that the null hypothesis is true, so meaning someone have gotten a result which is more like an evidence that actually supports the alternative hypothesis in a situation where the null is true. That kind of probability is what we call p-value. So p-value is a situation where you obtain an extreme result in support of the alternative when we can actually tell that the null hypothesis is what? Is true. That is when we say p-value. Now, there are some rules over here. Usually, we compare the p-value to significance level. And remember I told you the significance level is the rejection region. And usually if significance is 0.05, meaning confidence is 95%, it means the significance is 0.05. So what that means is that the more this probability gets closer to the significance level, the more we are rejecting the null hypothesis, because this is the error region, rejection region. This is the rejection point. So the more the p-value is coming closer to this, it means we are rejecting the null hypothesis. Okay? So if p-value is small, evidence is what? Strong. Evidence is strong. You reject H naught. Now, if p-value is large, evidence is weak. You fail to reject H naught. Okay, so the more the p-value, so for example, if you are having a p-value that is coming closer to the rejection region, it means you have to reject H naught. But if the p-value is large, it means the evidence is weak, so you have to fail to reject the null hypothesis. But remember, we always compare p-value to the significance level. So for example, if you have a significance of 0.05 and the p-value for a particular variable is set at, let's say, 0.01. You see, 0.01 is smaller than this. What it means is you have to reject the null hypothesis. And in such a situation, you go behind the alternative hypothesis, meaning the evidence is strong. So you have to go. But in a situation where the significance is 0.05, your p-value is, let's say, 0.7. You see, this one is bigger than this. In such a situation, you fail to reject the null hypothesis. Then you go behind you fail to reject the null hypothesis, meaning there is no relationship.